All right, 7.3, practice. Indirect measurement for similar triangles. Let's get after this. So number one, it says in a lot of these problems, the hardest part is kind of getting them set up. Once you get them set up, it's not too bad. But start off pretty straightforward. So we have a tree with a shadow. We have a guy with a shadow. So let's kind of just knock this one out. So tree, shadow, and the shadow is actually down here on the ground. All right, you don't really see the shadow flying through the air. It's down on the ground. So if the shadow is 12 feet, the tree is 24. Then I have Brad, Stickman Brad over here, and he's 6 feet tall, and we're trying to figure out his shadow. A couple different ways to do it. You could set up a proportion and do like height to height. So big height to little height, and then do big shadow to little shadow, and you could cross multiply and solve that. That's kind of a classic straightforward way. Get the answer 3. But you also could just kind of look at it and say, well, the shadow is half the height, so this shadow has to be half the height. So some kids are just kind of being good at seeing the patterns and seeing the numbers, and sometimes you can sidestep some of the algebra. All right, moving on down, number 2, we have a flagpole, 25-foot shadow. So I'm not going to put a lot of decorative stuff in here. Flagpole, shadow. Then you have a building. So this obviously isn't drawn to scale because the building is supposed to be 200 feet, but whatever. Doesn't have to be to scale. And need the shadow. So same idea here. You could set it up and do like height, little height, big height, little shadow, big shadow. I kind of see that the height is actually 5 times larger. So I'm just going to kind of bump this up 5 times larger, and I'm going to get 125. So I think that would be the right answer, but it's probably the same as if you would have cross multiplied. You get the same thing. So it just kind of depends on numbers and what you see. Now number 3 is quite a bit trickier, so I would be careful when you get to number 3. This one is one that is commonly missed. So we have the ground, and we have this lamp post. So I'm just going to kind of draw just kind of a big stick there for my lamp post. And it says, a girl stands 360 centimeters from the lamp post. So horizontally, she's over here. And she's 360 centimeters from the post. And it says she's 160 centimeters tall. So she's 160 tall. Her shadow is 90. Okay? So the girl's shadow coming to the lamp, is up here. It's got some sort of light coming off of it. And it comes down and hits her and creates a shadow on the ground. Now, her shadow is 90 centimeters long. So 90, let me make it a little bit fatter there. 90 goes from here to here. And now they want to know how tall is the lamp post. So we need to find this height over here. You call it X, you call it H, whatever. Well, this one's a little bit trickier because you can't just stick these 3 numbers into it. This is actually a situation where you have a triangle inside of a triangle. So you have her little triangle right here. So you got her little triangle. And then you also have the big triangle, which if you notice, the bottom is actually both of those numbers combined together. So I call this an overlapping triangle kind of scenario. So let's just kind of blow it up big and separate it. It's a little bit easier to see. So if I kind of separate things out, this is what we have. We have, I don't know the height, and this length down here is all of this together. So it's 360 plus 90. It's actually 450 when you add those two together. And that's the shadow of the actual light pole. And then her shadow is 90 and 160. Now we could set it up. But this number is where a lot of people kind of struggle and they go wrong on this problem. So be careful. Don't be one of those people. But I'll go big height, little height, or lamp height, person height. And then we'll go big shadow, little shadow. And, you know, there's some different ways to attack this one. But if you just straight up cross multiply, shouldn't be too bad. You end up getting, I put X down here, but you end up getting the height to be 800 centimeters. So number 3 is a tough one. Be careful on that one. Number 4, this one, let's see what's going on. We have a tower cast a shadow 7 meters long. We have a vertical stick. So we have a tower. Call this T. There's our tower. Cast a shadow 7 meters long. So that's the shadow on the ground. A vertical stick, like a meter stick or something, casts a shadow that's 0.6 meters long, and the stick is 1.2. So, you know, we could set this up T over 1.2, and then 7 over 0.6. But if you just kind of look at it, you'll notice that the stick height is twice the shadow. So this height should be twice the shadow. Either way, you get 14 meters there. All right, moving right along. Number 5. What do we got here? Tree, another tree. All right, this one's pretty straightforward. I'm not even going to draw trees. I'm just going to draw heights and shadows and heights and shadows. So, tree with a height of 4, shadows 15. How high is another tree if the shadow is 20? So it's going to be a little bit taller. So height over height, shadow over shadow, and we get 80 equals 15x. Divide both sides by 15. And it looks like we get 5.3333, which is 5 1/3 feet. Well, 1/3 of a foot, since a foot's 12 inches, a third of that would be 5 feet 4 inches. So 5 feet 4 inches. Or if I want to use the symbols, 5 feet 4 inches. Number 6. This one's a little bit different. So Luisa began walking up a hill at a spot where the elevation is 0.9 kilometers. So let's just kind of put this little hill going up here. And then we have the ground down here somewhere. Well, she starts walking at a height, the elevation above ground is 0.9. So she's starting off at 0.9. She walks 3 kilometers. So she goes 3 kilometers up. And at that spot, it says the height is 0.95. So it looks like she went 3 kilometers and she increased by 0.05. Well, if she keeps going up a hill like that, the next height's going to be 1.0, and she will have went another 3. And then if we go up again, that would be another 3. And it says she's going to 1.1. Oh, actually, I screwed that up. That's not 1.5. That's 1.05. That's 1.00. So one more would put her to 1.1. So it looks like she's got to go a last 3 here. So how far will she walk total? Looks like she walked 3, 6, 9, 12 kilometers. So that's the answer to number 6. Number 7, this one is a lot like the light post shadow problem. So we have the ground, we have a building right here, and it says the foot of a ladder is 1.2 meters from a fence that's 1.8 high. The ladder touches the fence and rests against the building. So we kind of have this fence right here. And then we have our ladder that rests against the top of the fence and then touches the building. All right? So, that's kind of what we got going on right there. And let's get some numbers on here. The foot of the ladder is 1.2 from the fence. So we have 1.2 is the bottom of the ladder to the fence. The fence is 1.8 high. So that's there. The ladder touches the fence and rests against the building that's 1.8 behind the fence. So the building is 1.8 behind the fence. Kind of weird, we got two 1.8s in there. Draw a diagram to determine the height on the building that it reaches. So we need to find how high up this ladder actually can reach over here. So we have overlapping triangles. So I always suggest with these, it's easier to separate them, kind of get both pieces, and it's a little easier to see. So my small one, let's just kind of make this red. My little small rectangle there, well, he is 1.2 and 1.8. And then my big triangle, the whole bottom there is a total of 3. That's the whole bottom. And we don't know X. And so now we could set up a nice little proportion. And we could say like side to side. And then bottom to bottom. Little cross multiply action. You get 1.2x equals 5.4. And then divide. And that comes out to be, I put that in my calculator earlier. Looks like it comes out to be 1.8 over x. 1.2 over 3. Looks like I didn't put this in my calculator. Oh yeah, I did. 2.7. Actually, I'm going to punch it in. I don't trust that answer there. 5.4 divided by 1.2 is 4.5. So it looks like 4.5. All right. So number 8, we got soccer field here. And so I'm going to draw my soccer field. Soccer field is 120 yards by 64 yards wide. And what dimensions would drawing be if the field were 1/4 inch equals 10 feet? All right, 1/4 of an inch is 10 feet. So there's more than one way to do this, so if you do it different than me, that's totally fine. I like to use this conversion right here, and I like to say 0.25 inches is 10 feet. So there's my conversion. But now I need some feet. So I'm going to change these yards. I know that for every 1 yard, there's 3 feet. So if I times these numbers by 3, I'm going to get 360 feet. And over here, I'm going to get 180. I got 192 feet. So now I have some feet there. So on my drawing, let's just kind of do my little drawing. And we'll call this the length. And we'll call this the width. So we have the drawing is here. The actual is here. So 0.25 inches on a drawing represents 10 feet in real life. So when I break this thing down, how many inches is my drawing going to be if I'm 360 in real life. So now we just got to cross multiply. 10x equals a quarter of 360 is 90. So x equals, so it looks like 9 inches. So that's going to be my length. I guess I shouldn't have used x. It's actually the length, but so my drawing is going to be 9 inches here. To do my width, I'm going to kind of go the same way. 0.25 inches is 10 feet. And so what would my width be if we're at 192 actual feet? So I cross multiply, and I get 10W is a quarter of 192 is 48. So it looks like W would be 4.8 inches. So I now have the dimensions. It's going to be 4.8 inches wide by 9 inches long. That one's not easy. That one's kind of tough. Number 9, final question. We'll rock this out. So a metal support brace is added to stabilize a triangle. So this is our support brace right here. So if I look at my top triangle, that should be similar to this big triangle because it's parallel. It's got a similar support. So when I draw the big triangle, it looks like this side is 4 plus 6 more. So we're looking at 10. And then the bottom is 18. Well, then the little blue triangle, I got 4, but I don't know how big the brace is. So there's kind of my setup. The big thing is people accidentally put a 6 here instead of a 4, but you got to add them both. So let's just set it up. 4 is to 10, side to side. Little bottom, big bottom. Boom. I got 3672 is 10x. So x equals 7.2. So final answer would be 7.2 feet. All right, hopefully that helps you out and gets you ready so that you can kick some butt on the quiz. See you.